So again, you can get the recorded version of this live session. Then the big piece for today, two big things. One is that your worksheet from Friday. So think about Friday, we did lesson 619 and you took a worksheet home with you to work on for homework. Actually, no one turned it into the tray on Friday, which means that you are going to need to take a picture of the front and the back of that document, and you need to submit it right here on this assignment. So I'm going to go ahead and click on it so I can show you kind of what that looks like. It says take a picture of the front and back of worksheet 6.19 and upload those pictures here. You can insert them into one Word document or you can upload them separately. It's your choice. It looks like somebody even already maybe submitted that. That's pretty cool. So you'll want to make sure you do that at some point today. And then this is going to be a link to the answer key for that sample test we're about to go over right now, because we're not going to have time and or you may not ask all the questions to go over all of it. So again, today it's the live Skype session going over Unit 6 sample test. You need to submit worksheet 619 by taking a picture of the front and back. My algebra students shared yesterday that it's probably easiest to use a phone and then try to either email those pictures to yourself that way. Then you can save them to your computer and then you can upload them into Canvas. It's probably a lot more difficult to try to take that picture with your computer, but maybe you're better at that than I would be. Okay, so let's get that document opened up. Here is the sample test. Let's see if anybody else hopped in. Okay, so there we are. So here's the sample test. What you'll have to do is just unmute yourself. Remember, there's this little microphone down here. You just click on that and you can let me know either which question you want me to work out or which ones you want to know the answers to. I can start with the first one and just keep going and see how far we get, but I don't think we're going to get through the whole thing. So if there was a question you thought was more difficult, then you need to make sure that you're asking which one you want me to go over. So at this point, I'm just kind of handing it over to you. If there aren't any questions or you don't want to see anything worked out, then I'll say toodles and see you again tomorrow.
Will you do 4, please?
I sure will. So I also noticed this document, because it was originally it was a PDF, it did some weird things with some of the boxes, but okay, so it says deep sea spider crabs live at depths of negative 150 meters or lower. So remember, when we're talking about water and depths and we use a negative number, that means we are below sea level. A submarine sets out to study the crabs in their natural habitat. It begins at negative 20 meters and descends steadily at a rate of 12 meters per second. Write an inequality that represents, that was probably a t, it just didn't copy it over, a t, the time in seconds until the submarine is lower than negative 150 meters. So a couple things are going on here. We have its starting location, and we also have the rate at which it is descending. Because it is descending, we want to make sure that that rate is negative. So if we start at negative 20 and we are descending at 12 meters per second, so if we take negative 12 times the time, we need to find out when the submarine is less than negative 150 meters, or how long it's going to take is really what we're doing here. So negative 20 for the starting location. It's a minus 12 because it is descending. You could also have there a plus negative 12. You could have negative 20 plus negative 12t, and that's less than 150. So there's your inequality. I don't know what this, why is it, I don't know why it was flashing at me. Okay. So that's the inequality. Now we have to solve it. So remember that when you solve an inequality, it's a lot like solving an equation. We were at a point where we were changing them to equations, and then we were solving them and using that number as our number of focus. So we can do it that way, or we can solve it just as the inequality. Which would you rather do, Haley? Do you want me to switch it to an equation or keep it as an inequality?
An equation would be easier, I think.
Okay, so let's do that. Because there is that weird rule about flipping the symbol and dividing by a negative. Okay, so when we have an equation, remember that we're going to get rid of the number first by adding 20 to both sides. When we add 20 to both sides, we get negative 12t equals negative 130. And now we need to divide both sides by negative 12. Dividing both sides by negative 12 does give us a decimal, and I can't remember off the top of my head what it was yesterday. So I'm going to use a calculator. Negative 130 divided by negative 12, yes, is 10.83 repeating seconds, or that's 10 and 5, 6. I think we're talking about seconds, yeah, seconds. So remember, when it's an inequality and you're asked to solve it, now we need to put it on our number line and figure out, well, what numbers work here and what numbers don't work. So in the middle of the number line, so that's going to be right here, we want 10 and 5/6. And then we need to decide, well, are we shading to the right or are we shading to the left? Remember, this number is not included. What's happening at this exact second? At this exact second, we are at negative 150. But remember, it wants to know when the submarine is lower than that. So not when it's at 10 and 5/6, but when it's lower. So we're going to put an open circle there.
But it says 150 or lower, not lower than 150.
No, it does say until the submarine is lower than negative 150. It can go to depths of that or lower, but we're trying to write an inequality for the time when it is lower than negative 150. Does that make sense?
Yeah.
Okay. So if we check a number like 0, remember we go back to our inequality. If I plug in a 0 up here for t, this all becomes 0, and I get that negative 20 is less than negative 150. That is not true. Remember that 0 is somewhere over here in my number line. Numbers get bigger. We read them from left to right, which means we're going to shade to the right. So the solution for the inequality, because we typically write solutions for inequalities as inequalities, not as equations like we did here, we would say that t must be greater than 10 and 5/6. Is that good?
Are we able to put t's greater than 10.83 repeating?
Absolutely, yes. And you can put 10.83 repeating on your number line as well. Just make sure you have the repeating bar. Did you get that right?
Yes.
Cool, good job. Can you see on my screen, can you guys see my taskbar? I think it shares my entire screen. I don't know why this is flashing like this. Is it just...
Yeah, we can see your taskbar.
Does it just mean... Oh, Gage is here. Hi, Gage. Does it just mean... Must just mean I'm in a session.
No,
It means that someone messaged you.
Oh, okay. Well, let's also remember that I do have... I can see everything that's happening over here. I also heard yesterday there were lots of like group conversations going on in the background, like maybe without me included. So I mean, obviously I can't stop that from happening, but because that was happening, students were missing that you didn't have to do worksheet 622 last night for homework, and I know a lot of kids did it, so just make sure you're paying attention. I mean, you're here, you're sitting in here live with me, you might as well pay attention, right? Okay, what else from the sample test?
Wait, I have a different question.
Sure.
So you said that the 619, when was that given to us?
Friday. Actually, it was given to you that day that you picked up that huge packet of worksheets. And I stapled them all together.
All right, I have it.
Okay, so for 7,
Yeah.
it says that the ski lodge can dispense 11 cups without turning off.
Uh-huh.
I'm confused on when I was figuring it out. I'm confused if I had to take it to an extra step because it said it turns off when 10 or less ounces of hot chocolate remain. I subtracted 10 from 112
Okay, good. So that means when's the machine going to turn off?
at 102 ounces.
Correct.
So I just wrote that whatever number I got had to be less than 102.
Right, exactly. So on that first question, it says starting from a full machine, which is 112 ounces, can it dispense 11 cups without turning off? Well, when does it turn off? It turns off when there are 10 or fewer ounces, which means 112 minus 10 is 102. So now we really want to make sure that we still have more than 102 ounces. So if you do 6.2 times 11, you get 68.2 ounces. So it would not turn off here. On the second part, you would do 6.2 times 18 because it's asking now, could it dispense 18 cups? And 6.2 times 18 is 111.6. But remember that it turns off at 102 because that's 10 or fewer ounces. So it would not...
I thought it was when there was 10 ounces less, like at the end of when they take hot chocolate out.
Right. The machine turns off when 10 or less ounces of hot chocolate remain in the machine. So if the machine can hold 112 ounces, that's great, but it's going to turn off at 102. It's going to turn off at 102. So here it would turn off. But here, the first one above that, it would not turn off.
So when you do 6.2 times 11 and you get 68.2, wouldn't you take 112 and subtract 68.2?
Well, yeah, sure, you could to see how many ounces are going to be left. But yeah, sure, absolutely you could. But we also know that because it holds 112 and it shuts off with 10 or fewer, that means it's going to shut off once you've used 102 ounces or more. And here in this first part, we only use 68.2. So I feel like I could explain it in words, or you're welcome to show 102 minus 68.2, but that you still have ounces left.
Okay, I thought you were saying that when there's 102 ounces left in the whole machine, that it would turn off.
It does. No, sorry, when it's used 102. When you've used 102 ounces, then it shuts off, because that would be 10, there would be 10 left. Maybe I did say that. I might have said it wrong.
Okay.
Okay, any other questions?
Yeah.
Okay, which one?
Still on 7. I'm confused on the equation.
Okay, do you want me to just do the whole thing?
Yeah.
Okay, so the next question asks what C stands for in that expression, 112 minus 6.2C. C stands for cups of hot chocolate. The next part asks what the expression represents, and what this represents is kind of more of what Haley was talking about. Take that number and then subtract it from 112. This represents the number of ounces left after C cups are dispensed. The number of ounces left after C cups are dispensed. Then write and solve an equation to determine the cups the machine can fill without turning off. So you can do this one of two ways. We want to take 6.2C and we want to know when it equals 112 minus 10, or you could just simplify that and say 6.2C equals 102. It also asks you to solve it, so we divide both sides by 6.2, and we get C equals, grab my calculator, I think it's 18 point something. 16 point something. 16.45, we'll just round. 16.45 cups. So then it asks to write an inequality. Well, that's, remember when we switch from inequalities to equations, we're just switching the equal sign to an inequality symbol. So the question here is it less than 102? Is it less than or equal 102? Is it greater than? Is it greater than or equal to? So which one is it? We want to know without turning it off.
Is it less than or equal to?
So that's a good question. If it's less than 102, this is, again, it's less than 102 being used. It's not going to shut off. But when does it shut off?
When it hits 102 or higher.
Okay, so do we want to include 102? It says we're supposed to be representing how much it can fill without turning off. And since it will turn off at 100,
then we need to include 102.
No, we want to know, we don't, because we want to know how many it can fill without turning off. It turns off at 102, so we don't want to include it. So then when we divide by 6.2, obviously we're going to get the same number we did before. C is less than 16.45, but now the conversation is, can we have 0.45 of a cup? No, we cannot. So it says explain clearly what the solution to the inequality means in the context of the situation. And I would even go then and say C has to be less than 16. Well, actually it could be equal to 16 in this case, can it? 16.45 is our max. So we could include 16 now. 16.45 would put us at 102. So anything less than that, even 16.4, would keep us underneath that. So what this means is this machine can dispense 16 or fewer cups of hot chocolate. And now I want some hot chocolate. Okay, any other questions?
Could you do 5?
Yep. So this is expanding, factoring, and simplifying. So this is what we were working on Friday. When it asks you to expand, that's the same as distribute. So we're going to distribute that negative 1/3 through the parenthesis. Negative 1/3 times 6 is negative 2, so we get negative 2x. Then remember, when we have a negative number out in front, that's going to change that sign inside. It's actually going to change both signs. Notice it made this term negative. It's now going to make this a positive because a negative times a negative is a positive. And 1/3 times 15 is 5. So the answer is negative 2x plus 5y. Letter B wants you to factor, so that's when you look at the numbers and the letters, the numbers and the variables, and determine which of these can I factor out of the expression. So when I look at 24 and 56, I'm trying to find the largest number that evenly divides into both of them, and that's going to be an 8. I also... Wait. Sorry. What?
So for number 5, is it okay if I put negative 2x minus negative 5? Because that's what I put before.
Yes. Yeah, if you put a minus negative, that's the same thing as adding a positive. I just don't ever do that. Okay, so again, we're looking at 24 and 56, and we're looking for the biggest number that you can basically factor out or divide out of both of those numbers evenly. So it's going to be an 8. I also shared Friday that if the front term is negative, you're actually going to need to take out a negative number. For some reason, they just think math people think it looks weird when you have a negative term inside that parenthesis. So now you're just asking yourself, what do I multiply negative 8 by to get negative 24x? Well, negative 8 times 3 is negative 24, and I still have the x. So now think, if I distributed this through, if I multiplied negative 8 times 3x, do I get this? And you do. Also, we have to be careful here because there was an addition sign, but I factored out a negative number. And when you factor out a negative number, it's going to change that symbol to subtraction. And what number times 8 is 56? And that's a 7. And you can always check your answer on these. If you were to redistribute that negative 8 back through, you should get the expression that we started with. Letter C is asking to simplify the expression. I'm going to write it all out in one big long string, so maybe it makes a little more sense or we can see it a little better. But it says 6x minus 6 plus 4x minus 5. And remember, we worked with rearranging. So if I put the 6x and the plus 4x together, and then I put minus 6 minus 5 together, you can kind of see a little more easily where our like terms are and what we have to combine. So if I have 6x's and I have 4x's, I now have 10x's. And if I'm subtracting 6 and then subtracting 5, that's the same as subtracting 11. So we're combining like terms in that last expression. Okay, what else?
For number 3, on the first equation, I didn't think that it matched, but it still just doesn't make sense. Could you explain it?
It does not match. This is not equivalent. So if what's happened here is it looks like they've simplified, and it's hard to tell when a wrong answer is placed what the thought process was. You know, how would students get a 12x? The only thing I can think of is that maybe in here a student might combine those and say 3x, and then because I see a 3x and I see a 9x, maybe they're thinking, okay, then students would also combine those and get 12x. But you are correct. It does not, it's not equivalent. When you simplify this expression, so again, we have to be really careful with this subtraction sign out in front. We can even put a 1 in front of that parenthesis. So hopefully maybe you see, okay, that 5x becomes negative and the minus 2 becomes positive, and now we have the plus 9x. And when you combine these like terms, it's 3 plus 2. Remember, the symbol goes with the number right behind it, and that's 5. And you have a negative 5x, and we're adding 9. So that would be a positive 4x. So that's what the expression is correctly simplified, or when you combine like terms. And so this one obviously does not match that. You would want to check these other 4. Which ones of these are going to give you 5 plus 4x? And there are 2 correct answers in there.
I got the second one and the fourth one.
Correct. Yes, it's this one and this one. And on those, you don't even really have to really simplify them to see if you would get this. You can look and see what does it match here. What they're trying to show you is that, remember that when you move around a number with subtraction in front of it, you have to take that subtraction sign with it. You're always going to be subtracting 5x no matter where you put it in the expression. Okay, what else?
Jackson says he can't hear.
Okay, all of a sudden?
I don't know if anybody can hear, but I cannot hear you, Miss Herbst.
You. Leave the convo and rejoin. That worked yesterday. Okay, so we'll see if that works. If not, the video, remember the video is available on Canvas after we're done here. Okay, any other questions?
Miss Herbst.
Yeah, hi, is that Mercy?
Yeah, hi.
Morning.
Did you end up getting mine from Morgan?
Not yet, I haven't seen her yet this morning, but I'll
Okay.
find her at some point.
All right, thank you.
Yeah. That's what I should check, is maybe who else is in here, who joined in. I
I
said
can hear that.
I said this yesterday, you guys, you know, it's going really well. It seems to be going well in terms of, you know, doing these live lessons and talking to you and communicating, but gosh darn it, I sure do wish you were all here. I know how to fix the not hearing thing. Ooh, what do you do? Make sure his volume's up. I mean, his volume was up because he was hearing me, right?
I can hear you now and it's working.
Okay, still cutting out though?
Somewhat.
Okay, and that's just, you know, probably just a glitch with the system. But it was weird that you were hearing me and then all of a sudden you weren't. So it could be bad connection. Yep, it could be your internet. Do you live in the country?
Yeah, I can. And I have really terrible internet.
Okay, yeah, do you see the phone thing down in the right corner? Yeah, what do you do with that? Hang up? Click it. No, that hangs it up. Oh, no, this phone thing. This phone thing? No. Yeah, this thing. Click it. Oh, there's volume here. I'm gonna make sure that's turned up all the way. Huh. Cool. I didn't know that was there, so I'll show that to other students when they can't hear. His could have been an internet issue, though, just because he was hearing me and then all of a sudden he wasn't. Okay, so I'm going to go ahead and wrap this up. I am going to post this video onto Canvas.